Lesson 1C, Elements and Protons. Recall the subatomic particles. Protons have a mass of 1, a charge of +1, and reside in the nucleus. Neutrons have a mass of 1, a charge of 0, and are also found in the nucleus. Electrons are almost massless, have a charge of -1, and travel around the nucleus in a path called orbitals. Let's look at our first example of an atom. This atom has a single proton, has no neutrons, and has a single electron. The single proton makes it so that the atom's atomic number is 1. Looking at the periodic table, we find the element with an atomic number 1, or simply has 1 proton in its nucleus, makes this atom a hydrogen atom. So this atom has an atomic number of 1. It is hydrogen. It has a single proton. It has 1 electron, so it has a +1 charge from the proton and a -1 charge from the electron. They cancel one another out to make a neutral atom. We can also say it's elemental. The mass of the atom is 1, since only protons and neutrons give the atom mass, and there is no neutrons, just a single proton. Is this the most common mass for hydrogen? If we look at the periodic table, we can see the atomic mass of hydrogen is 1.0. This is the weighted average of all the hydrogens in the world. So yes, this is the most common mass for hydrogen. This next example has 2 protons, 2 neutrons, and 2 electrons. The atom with 2 protons is helium. The atomic number is 2. It has 2 electrons, so again the atom is neutral or elemental. It has 2 neutrons. The mass of this atom is 4. The mass comes from the 2 protons and the 2 neutrons. Is this the most common mass for helium? Again, we refer to the periodic table. Helium's atomic mass is 4.0. So yes, this is the most common mass for helium. The last example has 3 protons, 4 neutrons, and 3 electrons. According to our periodic table, it must be lithium. The 3 electrons, which balances out the 3 protons, we have a neutral atom or elemental lithium. And the mass number is 7, from the 3 protons and the 4 neutrons. Looking at our periodic table, we can see the atomic mass for lithium is 6.9, which means there are likely some lithium with a mass of 6, but most will be a mass of 7. This is the weighted average mass of lithium, 6.9. Yes, a mass of 7 is the most common mass for lithium. As you can see, with our 3 examples, when we increase the number of protons, the most important thing that occurs is the atomic number changes, which means the type of element it is changes as well. Look at this example of chromium, written in standard notation. It has a mass number of 55 and an atomic number of 24. If we add 3 protons to the nucleus, what happens? Well, the number of protons increases to 27, and now it would become a different element, cobalt. The mass would also increase by 3 to 58, since each proton has a mass of 1. In our next example, we use the same chromium. If we remove a single proton from its nucleus, what will happen? Well, the atomic number would decrease, changing it to vanadium, but its mass would also decrease from 55 to 54. Note both the atomic number and the mass number changes. In summary, changing the number of protons changes the mass of the atom, the mass number. It also changes the number of electrons if the atom is to remain neutral, but most importantly, the atomic number would change, making it a different element.